All right. Welcome to the third session of day 2 of the 2021 IoT and Edge Days at the Eclipse Foundation. Today, I have with me an amazing two gentlemen from Red Hat. I have Jens Reimann and Dejan Bosanac. Jens is a principal software engineer at Red Hat. He has been a software engineer on M2M related tasks since 1999. So we're talking about 22 years ago. Over the years, he progressed with industry towards what is now called the IoT. Jens have always been a fan of open source and helped different organizations to conceive the Eclipse IoT top level projects. Although he's a contributor in numerous number of open source projects, it's Eclipse IoT and Eclipse Hono where he feels most at home. Dejan, he's a software engineer also at Red Hat with an interest in open source and integrating systems. He has been involved with the numerous and various open source communities and tracking problems and on top of resolving problems related to IoT, cloud platforms. Eclipse IoT and Eclipse Hono is one of the key areas, I might say. The floor is yours, gentlemen. Just before I wrap up, I wanted to bring to your attention and everybody's attention from the attendee side that we'll be allocating around 10 minutes for Q&A by the end of the session. So please make sure you write your questions down on the right side of your screen or click on the Ask Question button, and then we'll get to your questions and answers by the gentlemen. Jens, Dejan, the floor is yours.
Thank you.
Thanks. So welcome to this session and thanks for your interest. Today we want to talk a little bit about digital twins and how they can fit into the cloud native IoT environment. We'll cover Eclipse Ditto, we'll cover a little bit of the Knative project concepts and a new project that we started within the Red Hat, the new initiative called the Drogue IoT. So let's get started. One of the things is try to frame the problem we are trying to solve, and basically, every cloud IoT platform that we start to look at least from the telemetry point of view, looks something like this. We have on the left side a lot of devices sending a lot of data with different kind of formats through different kind of protocols. And then we have this question mark blue box in the middle, trying to make sense of this data and basically onboard these devices to be usable on the other side. What the blue box basically is creating is event stream of sensor data in this use case. And usually on the right side we have three types of applications that are generally deployed. So we can have our own custom application, right? Which for telemetry sensor streaming is a kind of streaming consumer and event stream application. Then people usually deploy some kind of observability stack containing some kind of time series database like InfluxDB combined with some kind of dashboard like Grafana for easy visualizing different streams coming from the devices. And the last but not the least, we have the concepts of the digital twins that we will cover in a little bit more details today. And the digital twin, the basic idea is for them to try to provide to solve two problems for us, right? So they need to handle this event stream and coming from the sensors, and they need to help us control the state of the actuators on our devices. So how they're gonna do that? And if you take a step back and take a look at all of this. This event stream coming with the IoT telemetry is not that different from any different kind of event stream we are dealing in today, the distributed systems. So what digital twin needs to provide for us is kind of a materialist view of the stream. So provide the state for this data data coming from a device, and make that data queryable, right? So what we want to do is that even if our device is offline, we want to know the last known state of that data, and that we can query and provide a developer API to access the state of the device. In a other direction, when we try to actuate devices and change their state, we usually say that we send commands back, right? And sending commands back is kind of imperative style programming, right? What we want to do in a distributed systems is to basically have a declarative state of a system. So basically, we want to say what the state we are expecting the system to have, and have some kind of have our distributed system reconcile that state to the actual state. For that, we usually use something that's called reconciliation loop pattern. Basically, the system will observe the actual state of the device by reading its sensor data and try to send the commands to actually bring the actual physical device to our desired state. This is a common pattern in distributed systems that's proven to work very well and scale very well with a wider range of resources that needs to be managed. And in my opinion, it's even more relevant in the IoT use cases because the IoT application is a distributed system, pushed to the limit, because it's not just cloud resources you're managing. You're managing a physical state of the devices. So our digital twin, in this sense, needs to provide some kind of a reconciliation loop and provide us with an easy way to declare desired states of our devices and take the job from that point on and try to make that happen. Eclipse Ditto is a implementation of digital twin and Eclipse project. It's based on the ECA actor framework, and it uses the MongoDB for the persistence of the device state. We'll go a little bit through the detail in the coming slides. Important for now is to mention that it comes with a wide range of connectivity options. Well, it can consume from MQTT or HTTP or different kind of. You can connect it to the Eclipse HONO as well, and it provides HTTP and WebSocket developer APIs. So what's at the root of the Eclipse Ditto is the concept of the thing, right? And how do we define the thing that we wanna use? And this is one of examples we use with the Drogue IoT that we'll show later on. Of course, everything has its own identity and the policy, then we defined a couple of features and the properties that we are expecting from this device. In this case, we are saying that this device is have a temperature sensor, and we are trying. We will save that value in a temperature sensor property. One more thing that's important to say here is that, as you can see here, we can define a model for this device, and this is how Eclipse Ditto play nicely with the Eclipse Worker, which is a modeling language for the devices. Eclipse Worker basically gives an opportunity to use a DSL to create a model for our device, and then that model can be mapped to different representations and different SDKs to work with that device. The important thing is to say that you can use Eclipse Ditto even without Warto, but in the case of the more complex devices, and if you want to evolve your schema over time, the model can be a good idea to have. So once we have our device, we can use Ditto APIs to interact with our thing. And on this slide, we have a simple example of the modify commands. So Ditto have a concept of the commands that we send to the API to interact with it. So you can see that by defining a proper topic with the ID of our device and the command we want to use, we can interact with our previously defined device. And in this case, we want to change its temperature value to say number 22 from the previously defined 23. And it's that easy to do using the HTTP API and sending this kind of a JSON payload to it. So the goal we want to do is to replace that blue square with the question marks with something that can help us in developing IoT clouds based on the cloud native technologies like Kubernetes, Knative, and Kafka, and see how we can help us to get our data from the sensors and from the devices going through this cloud native stack and then into the digital twin. But before we go to that, we want to give you a little bit of introduction to the Knative and the serverless, and explain basic concepts that we will discuss later on in the context of the IoT. Jens, would you like to take over?
This is where I jump in. So Knative is a Kubernetes platform to deploy serverless workloads. So it's built on top of Kubernetes. It was designed with Kubernetes in mind. There's a homepage to check out, but the idea is really to have some simple services and build them on top of Kubernetes cloud native in a cloud native way. On the next slide, we will see how that basically works with Knative eventing. So Knative consists of two parts: Knative serving, which is a service that you can access, or Knative eventing, where you send messages or events from one service to the other. So that's very common way of doing things. You have a source and a sink, or a producer and a consumer. There are different terminologies in different technology areas, but basically it's always the same. Someone creates an event and someone receives an event. And going on, of course, we have steps in the middle. So that's kind of a processor, transformer, also different names, but that's also one concept that we have in Knative. Now on the next slide, we can also see that you can, using Knative, create from those basic steps, you can create bigger constructs using sequence or parallel, which means that you have different steps in transforming. So maybe that can be in the sense of processing something, transforming from one payload format to another. You can filter, you can multiplex. There are all different kinds of ways to deal with your events in the middle. There's additional concepts like channel and broker or subscription. The channel and broker construct persists data, so that you not only have like what we saw before with the source and the sink, that's all like temporary data or influx data, but you also have the ability to persist data. And of course, there's like a little note here. There is an in-memory broker, which obviously does not persist memory, but it's easy to test with that. But if you have a broker backed by Kafka, for example, that of course persists data. So the question is, isn't there a gap? So source and sink, and this can be different technologies. That sounds great, but how does it actually work? Like, what's happening in the middle from sending to receiving? And there is where cloud events come in. So cloud events is a specification that defines what an event looks like. Knative eventing basically builds on top of that. And there are different specifications for different transport mechanisms. Like here in the middle, we see the cloud event has a payload. It has standard attributes, like an ID, subject, timestamp, the payload format, and the payload schema that comes in handy later. And you can, of course, put in custom attributes as well. Now, for example, if you take a look at HTTP, that maps like you see it right here. So in a JSON format, a cloud event might look like this. You have a spec version, you have a type, source, all kinds of stuff. And you can map this to an HTTP request, where in HTTP, you have the properties can be mapped to HTTP headers, and the payload is the payload of the HTTP request. And the same for Kafka. Kafka has properties where you can map the extensions or attributes of properties to Kafka property, and the payload to the payload of the Kafka message. So what are the benefits of Knative? This also goes a little bit into the direction of serverless. So what are the benefits of serverless or of Knative? First of all, it's language agnostic. So the source can be written in Rust, the step can be written in Java, and the sink can be in Python or in any other mix, because the interfaces between them is cloud events and is the cloud event standard. And also scalability. Now, these different steps are Kubernetes services, and you can scale them up, or of course you can scale them down, depending on how much message throughput you need. The good thing is with serverless, you can also scale down to 0. So that means that, yeah, the service is there, but it will only be fired up and consume resources if it's actually in use. Versioning is one additional thing that you get. So you have proper versioning of the services. You can go forward, go backward if you think that the version was not good enough. So you can go back to a previous version. You can split the load between the different versions to test a new version or test like A/B testing, all kind of things like that.
Okay.
Then there's Drogue IoT, and I hand back to Dejan.
Yeah. So what's the idea behind the Drogue IoT? It's basically what we're trying to do is to create an open source project and do the IoT with Rusty core, so to say. So try to use more Rust programming language, and we'll see about more of that in the minute. So the project itself consists of the two parts. First one is trying to provide a Rust-based, actor-based framework for writing a synchronous microcontroller firmware. And that's not the topic for the session today. But if you're interested into something like that, I call you to take a look at it. What we'll talk more about today is the Drogue Cloud. And the Drogue Cloud is an effort to provide an IoT as a service based on the cloud native technologies like Knative and Kafka, and try to use Knative and Kubernetes and Kafka in a natural way and provide IoT specific services on top of that. We also try to use Rust there as well as much as we can. And before moving forward, I would just try to say a couple of words of why Rust and what's the idea here. And the basic idea is that Rust, unlike Java or Go, is a no garbage collector programming language, making it very easy to create native code that's comparable with C and C++. Interfaces very well with C, and on top of that, it provides a different kind of memory guarantees that you don't get in C and C++. And of course, coming from that, you can see the benefits of doing embedded and microcontroller work with Rust. But also we see that using it for writing the serverless workloads is very good, because we have a very small and efficient binaries in containers, and that's exactly what we need for these so to say short-lived and easily scalable workloads that we have in a serverless infrastructure. So we want to have containers that are very efficient with the memory usage and can start and stop very fast. So that's the basic premise. And then if you go back and go into more details about our blue square with all the IoT bits we want to provide, we can see that we can use Kubernetes and Knative as a central layer on top of that, and then provide additional IoT specific layer. Basically, the one that is facing the devices, and that's dealing with the connectivity and protocols and device identities and device registry, and the other one facing the applications, right? And that part is usually dealing with payload mapping and normalizations, as we're going to see in a minute, integrations with different external systems, and even pre-processing of the data. How all this look in a little bit more details. As we said, cloud events, I think, is the center part of the serverless infrastructure and provide a lot of value. So you can see that the cloud events is basically the interface between the protocol endpoints, Kafka, and the serverless services that consumes that data and pushing it forward. And we also provide device authentication on the device size, and user and application authentication on the application side, and try to provide different kind of integration points so that you can also consume your data outside of the cluster that actually hosts the whole Drogue Cloud infrastructure. So how does this play along with the digital twin, right? So first thing that could be done is to basically create a new API for Ditto that talks cloud events. That will make it much more better fit for integration of the that API into the any kind of serverless infrastructure. So there is that now. And you can see that there's a new API ending with /cloud events that now talks cloud events, right? And it differs from original HTTP API in a fact that it consumes a properly formed cloud events that already again have a Ditto protocol and Ditto commands, the one as we saw in the slide previously, as a payload of that event. So what's now the job of our IoT infrastructure, serverless infrastructure to do, right? So we have our data coming from the sensors in different kind of formats. So let's say a simple temperature reading, and that's stored in our Kafka telemetry stream. And then we want to go to all to different kind of transformation to actually format something that's consumable by Ditto on the right side, and push that to Ditto. And you can see that these kind of workloads are basically ideal for the serverless infrastructure, because they're very small, stateless, and very predictive, and can be horizontally scaled without any issues, right? So in our example, we used a sequence that Jens talked about earlier, adding additional step to transform these JSONs from one format to another, and basically sync that results as a cloud event to the Ditto cloud event endpoint, right? So this is how a configuration of that sequence looks in practice, and you can see that it's basically consuming messages from the Kafka channel. It calls our service, which is named Worto Converter here, and we'll get into that detail in a minute. And a result of that conversion is again cloud event, which will be pushed to the locally hosted Ditto instance and its cloud event endpoint. So a little bit about the converter itself. The example we have at the moment in the Drogue Cloud is based on Worto. So basically, what you can do in Worto for every of your model, you can create a mapping for the incoming data format that you expect, and you can load that mapping into your registry, and there's a Java SDK that you can use that basically will get the schema from the from the Worto registry and do that conversion. We don't see that here, but what we see here is a general principle that could be very easily done. So this is built with a Quarkus as a simple Quarkus application. And as you can see from this pseudo code is that super easy to consume cloud events, do some data conversion, and then create a new cloud event that you will push forward. But the thing is that even without using Worto and without talking about digital twins, this is a basic problem that we see a lot into the IoT applications. This basic payload mapping, in this case JSON to JSON, it can be some binary data to JSON, and you can see that it's super easy to implement these in different languages. So we can do this in Quarkus. We can do this easily with in Rust with the JSON path as well, and it can be useful beyond the digital twins. So you need to do your conversion if you want to push your data to the time series database or some data lake. It's all pretty similar. So all you need to do is provide your Knative services to react to certain data schema and convert and push data further on in a proper schema, doing the data normalization. And we can also do much more there in terms of encasing data and things like that. And one of the goals we have, and we are very early in this process, is to be able to provide a very easy framework to do this in a couple of languages and support multiple environments and off-the-shelf projects like Eclipse Ditto. There's a couple more details that we implemented in the Drogue Cloud. So on top of the data plane, we also have a control plane, which consists of, as we said, device registry. We have an SSO instance and device management API. And one important thing here that we're trying to solve is, if you take a look at this arrow that's going down called the change events. So we are trying to solve the problem of synchronizing the resources between the multiple device registries. And this is not currently working with Eclipse Ditto, but it could in the near future. So basically, the problem is, and that's the problem we had for years in multiple IoT projects, is that every layer you take a look at has its own kind of identity system or register system for the devices it knows about, and we need to always to create some kind of a system to get them into the sync. In the Drogue Cloud, we try to use the event sourcing and implement the concept of the change events and use the Drogue device registry as a source of truth, so to say, which will generate events that can be acted upon and provide an integration with the external systems and services. So, for example, we can define a device that should be also provisioned in the Things network and the Ditto at the same time, and the Drogue will make sure with the appropriate controllers to do so. It tries to follow the problem pattern that's used in Kubernetes and that we talked about earlier with the commands as well, the reconciliation loop. So every of these integration points will try to have its own controller that will be responsible for synchronizing the data into the appropriate service. And as I said already, we also trying to support different kind of devices. So as we are working on the Drogue device as a embedded system, that's of course supported, but also we're trying to support more beefier gateways and edge nodes, and also IoT services such as Things network. So that's all I have to share with you today. And Jens, please add something if you think I missed. Here are a couple of links we have. So go to the Drogue.io to find more documentation. You can use our sandbox to connect directly and play with it without provisioning it yourself. And of course, you can join the community there.
Yeah, and I also would call out because you have the blog post in there from Microsoft. So that is a blog post from 2019 and explains the problems they face with C and C++ and memory issues, and why it's good to take the approach of using Rust, and Rust could have fixed that. So if you're interested in that, I recommend to take a look at that blog post that goes into way much detail. But it's a nice read.
Cool.
All right, sounds great. Thank you so much, gentlemen, for the great session. If anyone have any questions, please feel free to drop us a question on the Ask a Question side.
We're also always available on the Eclipse Slack channels. So if you wanna talk about any of these later on, it's easy to reach us. Here's
Exactly.
a question from the Frederick.
Yeah, from Monsieur Frederic. How is asking you, how easy is it for Java developer to get started on Rust?
Yes, you wanna take that?
Yeah. So it takes a bit to get into that, because in Java you just shift objects from left to right, and Rust enforces you to think about who owns that object or that structure at the point in time during your application lifecycle. So that is hard to go into that direction. But from experience, I can tell it's much harder to go back, because if you develop Rust for a while and then you start to go back, you suddenly miss all the different tools and features that you have in the language, and suddenly that is all gone, and the safety of it compiles and then it runs, that is gone, and you just fire up your Java application and start debugging then.
Amazing. I have another question for Shant Desai, and thank you, Shant, for your contributions in the different sessions, different questions. It's highly appreciated, and thank you for taking part of the questions and the back and forth discussions with the different speakers. So Shant is asking, Rust has a steep learning curve, and sometimes the dependencies in Rust is not very well maintained. So how do you gentlemen see that Drogue IoT want to make it more developer friendly? How does Drogue IoT want to make it more developer friendly?
So that's definitely a point, that dependencies are sometimes not well maintained, but that's similar in all programming languages that I saw so far. So I think the Java ecosystem has a very good ecosystem of dependencies, but still even there, sometimes dependencies, they remain unmaintained at some point, or you have a great new library and 2 years later that looks all dead. So I think that's a problem that we have in all languages. And I'm not starting to talk about JavaScript and the repository that they have where stuff gets unmaintained and the new hip dependency from yesterday is already the old one tomorrow. It's a similar problem. So in Drogue IoT, we try to focus on dependencies that are well maintained, that we can maintain ourselves in the case of that we need to make changes. That is an important part. And like working on Drogue IoT, we already contributed to numerous other projects trying to improve the situation or trying to fix bugs and issues, and helping out maintaining that. I think that's the reasonable thing to do if you do open source.
And as we said, there are two parts of it. One is focused on developing devices and the firmware for devices, and other part is trying to use more Rust in the serverless world and in the cloud world, and how we make it easier to build the cloud infrastructure with all this.
That's maybe worth mentioning. So if you use Drogue device, then that's a Rust-based framework for writing firmware. So you have to use Rust, of course. If you take a look at the Drogue Cloud side, that uses Rust for its own purposes, but it not requires you to use Rust as well. So the APIs, this is just standard APIs using MQTT, HTTP, all different other kind of technologies. But you don't need to use Rust. We do because we like it, but you can use whatever you like. We have a few demos now with Python and Quarkus and Java, so you're welcome to do that as well.
Sounds great. I hope that answered your question, Shant. But in all cases, the thing is with the IoT and edge topics, and and talking specifically about the cloud native digital twins and Zeno, it's an ongoing journey. The way I see it, it's an ongoing journey where we have lots of questions and queries, and especially if startups or even companies of different scale are really involved in the coding and the software development side of it. So in all cases, you can always reach out to the gentlemen from Red Hat, Dejan and Jens. Their Slack channels and emails has been added as well. So and part of this presentations will be, of course, available on our YouTube channel. So you're always welcome and free to go through this session again for any particular details. Thank you so much for the engaging session. It has been an amazing session today. We look forward to for a continuous, I would say, work on the different projects that Red Hat has been leading, part of the Eclipse Foundation. So thank you for being there for all of us, and thank you for being strategic member to the Eclipse Foundation. Again, I wish you all the best, and until we move on to the next session, I'll be giving you around 15 minutes, 20 minutes for all the attendees, to stretch your legs, take a break, take a coffee, drink some water, depending on the timelines we have. Until then, thank you so much, and we'll catch up on the next interesting session, which is going to be with Angelo Corsaro from AD-Link talking about the Zeno and the edge computing data fabric. So stay tuned for that. Thank you.
Thanks for having us, and take care.
Thank you. Cheers.